Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing a bridge rectifier with a filter circuit. In a center tapped full wave rectifier, both the positive and negative half cycles are rectified, so no voltage is wasted at the output. Furthermore, the DC output produced by the center tapped full wave rectifier is smoother than a half wave rectifier. However, the center tapped full wave rectifier has a drawback that it is a highly expensive type rectifier since the transformer used is a center tapped transformer which occupies larger space and more cost. So in order to overcome this drawback, a new type of rectifier known as bridge rectifier was introduced. In a bridge rectifier, the transformer is not needed. However, a total of 4 diodes are used in a bridge rectifier. The overall cost of the bridge rectifier is very low as compared to a center tapped full wave bridge rectifier. Like the center tapped full wave rectifier, the output DC of the bridge rectifier contains small ripples. These small ripples can be reduced if we use the filter at the output. The filter converts the pulsating DC into a pure DC, and the filter is made up of the combination of components such as capacitor, resistor, and inductors. Like the center tapped full wave rectifier, the bridge rectifier also rectifies both the positive and negative half cycle of the input AC signal. However, the construction of this bridge rectifier is different from the center tapped full wave rectifier. In a bridge rectifier, the diodes are arranged in the bridge circuit configuration. The bridge rectifier is made up of 4 diodes, namely D1, D2, D3, and D4, and the input signal is applied across the 2 terminals A and B, while the DC output is obtained across the load resistor RL connected between the terminals C and D. The pulsating DC output obtained across the load resistor RL contains small ripples. To reduce these ripples, we use a filter at the output. The filter normally used in the bridge rectifier is a capacitor filter. In the circuit diagram, the capacitor filter is connected across the load resistor RL. When the input AC signal is applied, during the positive half cycle, both the diodes D1 and D3 are forward biased, and during that time, the diode D2 and D4 are reverse biased. And thus, during this positive half cycle, the output is generated. On the other hand, during the negative half cycle, the diode D2 and D4 are forward biased. At the same time, the diode D1 and D3 are reverse biased. Thus, the bridge rectifier allows both the positive and negative half cycle of the input AC signal. The DC output produced by the bridge rectifier is not a pure DC but a pulsating DC. This pulsating DC contains both the AC and DC component. The AC component fluctuates with respect to the time, while the DC component remains constant with respect to time. So the AC component present in the pulsating DC is an unwanted signal, and the capacitor filter present at the output removes these unwanted AC components, and thus a pure DC is obtained at the load resistor RL, since both these capacitor and resistor are connected parallel to each other, and during both the half cycles, that is a positive and negative half cycle, the capacitor gets charged and it discharges very slowly with respect to the input applied voltage. So this will produce a smooth DC at the output terminal. So my dear students, hope you had understood this topic. So dear students, kindly write down the assignment question. Our question is, write notes on a bridge rectifier with a filter circuit. So dear students, see you soon. Until then, goodbye. Thank you and all the best.